h of x equals r of x. These are two logarithmic equations. The first one, log base 5 of x minus 9 equals log base 5 of x minus 24 plus log base 5 of x. Alright, got a lot going on here. Well, just like the previous example, we need to try to condense at least the right side. Log base 5 of x minus 24 plus log base 5 of x simplifies to be log base 5 of x squared minus 24x. Okay, addition can become a single logarithm that is a product inside. The left side, of course, stays the same. Okay, so now I'm going to use the rule that if I use 5 as my base on both sides, the exponential base, with the logarithm serving as the exponent on both sides, well then, the logarithms will cancel out, as will the exponential bases, to leave me with a typical x minus 9 on the left and x squared minus 24x on the right. Okay, so now to solve this is a quadratic. Let's subtract x from both sides. I'll use a different color this time so we can visualize it a little bit better. Subtract x from both sides and add 9 to both sides. And that will give me 0 equals x squared minus 25x plus 9. Okay, so ordinarily we would try to factor this quadratic equation, but that's not necessarily going to happen in this case because it's not factorable, which means we go next to the quadratic formula. Okay, so remember the quadratic formula uses the coefficients a, which is the number in front of x squared, in this case a 1, b, that's the number in front of x, in this case a negative 25, and c is the constant 9. And if you wanted to recall the quadratic formula, it's negative b plus minus the square root of b squared minus 4ac over 2a. Alright, so let's go ahead and plug in a, b, and c. Okay, so let's see, a is 1, a goes here and here. B is negative 25, so I'll put that here and here. And then C is 9, goes there. Alright, so now let's work this out. Negative 25 is going to be 25, positive 25, plus or minus the square root. 25 squared is 625. 4 times 1 times 9 is 36. 2 times 1 is 2. So 25 plus or minus 625 minus 36 is going to be 589 over 2. 589 over 2. Now the square root of 589 cannot be broken down, so I'm left with two potential answers. 25 plus square root of 589 over 2, 25 minus the square root of 589 over 2. Now I can convert these two to decimals so that way I can check to see if they both work as far as plugging them in. I cannot plug in a negative or a 0 into a logarithm, so I'm going to be careful here. 25 plus the square root of 589 divided by 2 is 24.6347. And if I do 25 minus the square root of 589 divided by 2, that comes out to be 0.3653. 3. Okay, so these are decimal approximations, which could be the answer, but let's go and check. If I plug in 24.6 into the original logarithm, do I get anything other than a positive number? If I plug in 24.6 here, that's fine, because I end up with a positive. 24.6 would give me a, or minus 24 would give me a positive 0.6. Same thing's true here. If I plug in 24.6, still have positive values. So I know that 24.6 is fine. And the number that it, of course, represents, which is 25 plus the square root of 589 over 2. Now let's check 0.3653. Okay, if I plugged in a decimal less than 1, that's going to be minus 9. That's, of course, going to present a negative number. Okay, so that one already fails on the first one. So this 0.3653, not a solution. So 25 minus square root of 589 over 2, not a solution. So here we go, exact answer and decimal approximation.